Okay guys, what I want to do is I want to take this idea and break it into 3 videos to try to keep the videos as short as possible. So there are a handful of properties of logarithms that make logarithms worthwhile. Okay, so what I want to do just in this video is sort of sorry, I had a brain fart. Just introduce the 3 major properties and introduce some vocabulary. And then in the following videos, we will work with using them. Okay? So first up, for this intro is I want to build on this idea that logarithms are really just the exponent in the relationship between 3 numbers. So since logarithms are the exponents, over here, I'm going to I'm going to review of a handful of exponent rules. Okay? So first up, there was an exponent rule that says if I have something raised to the mth power, some base raised to the mth power, oh, hang on. As I was writing, I remembered which side my microphone is on, and I think I may have accidentally covered up. Apologize if I was a little muffled for a moment. Okay, so if I have some base b raised to one exponent m times another base b raised to some other exponent n, we learned way back in Algebra 1 that I can combine those as a single base by adding those exponents together. Okay, likewise, let's pick this color. If I have the log base b of, I'm going to use capital M here, times capital N, it turns out that I can split that multiplication up as adding the log base b of one of those factors plus the log base b of another factor. What's the analogy here? For my exponent rules, if I multiply together 2 things with the same base, I can change that I can change that multiplication of these 2 numbers into adding their exponents. Okay? So this isn't a perfect one-to-one correlation, but there is an analogous thing here. If the log is the exponent, then I can turn multiplying these 2 numbers together here into adding exponents together here and here. The log is an exponent. The log is an exponent. Okay? Similarly, there was another exponent rule that says if I divide 2 things with the same base, pardon my poor division right there, my finger kind of trailed. I can fix that. Whoop. Okay. If I'm dividing 2 things that have the same base, just like multiplying, well, the opposite of multiplying is dividing, and so therefore the opposite of adding is I can subtract those 2 exponents. And there's a couple ways you can think about and talk about it, but let's just keep it simple. Let's just do top minus bottom works. Okay? Maybe you guys can anticipate the analogous one over here. If I take the log base b of, instead of multiplication, division, I can separate that division into subtracting the log base b of whatever I have on top minus the log base b of whatever I have on bottom. Okay? And the last handy rule sorry for being anal and trying to make my thing look perfect and elegant. I know it's not, but OCD is taking over. Okay, the last exponent rule says if I take the base of something raised to some power, and then I raise it to another power, another exponent, if I have exponents separated by parentheses like this, then I can get rid of those parentheses by multiplying those exponents together. Likewise here, there's a third property of logarithms that says if I take the logarithm, which is an exponent, of something, and my capital M and my capital N, these are representing anything, numbers, variables, expressions, anything in the world. So if I take the log base b of something raised to some power, I'm going to use a p for power, or exponent. Oh, that's a terrible parenthesis. Well, whatever. Okay. But if I take the log, which is an exponent, of something with an exponent, I can bring that exponent out front and multiply that times the log base b of whatever that base was inside the log. So what did I end up doing? I'm taking the exponent times the exponent. So if I have exponents with exponents here, I can turn that into exponents times exponents here. If I have exponents with exponents here, I can turn that into exponents times exponents here. Okay? So last bit of vocabulary to sort of set up the next two videos. This is my own personal vocabulary. I'm not the only one that uses these words, but I'm not going to say that this is universal. These are words that are universally used amongst mathematicians. This equal sign in these three properties go in both directions. All right? So sometimes I'm going to be given something that looks like this, and it's going to be handy to rewrite it like this. And sometimes I'm going to be given something that looks like this. I'm adding logs together, and it's going to be handy to rewrite it like this. So sometimes I'm going to go in this direction. Sometimes I'm going to go in this direction with all three properties. Okie doke. So I try to be as precise with my words as I can. So when I look at the left side of my equal signs here, they all have something in common. They're all one log base b of something inside. Log base b of something inside. One log base b of something inside. All of the interesting, unique stuff is inside the guts here. Okay? So I think of all of the interesting stuff as being packed up and condensed into one single logarithm. So if I want my expression to look like this side, again, this is just me and my own personal vocabulary, I call this the condensed form. But if I want it to look like this right side as a sum or difference or product of logarithms, I think of all of this as being unpacked. It's just inside is as simplified as I can make it, and all this adding and subtracting and multiplying is happening outside. I call this my expanded form. Okay? So if I want to go from something that's condensed to something that is expanded, then I would say expand this logarithm out. And it'll look like this. Or if I have something that looks like this and I want to pack it all up and condense it, that's the word I'm going to use. I'm going to say, okay, condense, and go in this direction. Okay? Before I end this video, I'm going to acknowledge two more properties of logarithms that, I don't know. Some people think they're handier than I think they are. But they are super duper easy, so I'm going to go ahead and acknowledge them. And again, there are analogous exponent rules that we can think of. So the fourth exponent rule that's super duper easy is if I take something and I raise it to the first power, I'm going to get that same exact number back. 8 to the first power is 8. Negative 3 to the first power is negative 3, so on and so forth. And The easiest exponent rule, which is also the one that seems the most magical and gives students the toughest time, is if I take something and I raise it to the 0th power for almost inexplicable reasons, not almost inexplicable. Maybe I'll do a separate video on that one day. I get the number 1. Not 1b, but anything at all in the world except for 0, raised to the 0th power is going to give me 1. Okay? So back to these properties of logarithms. Remember, the logarithm is the exponent in a relationship. So if I have the log base b of b, then I'm asking myself the question, b raised to what exponent is going to give me b right back? Well, duh. The answer is 1. And if I have the log base b of 1, then I'm asking myself the question, b raised to the what power is going to give me 1? B to the 0th power gives me 1. Okay? So that's our introduction. And again, the big thing for me is these 3 properties, and we will practice using them. We're going to practice expanding in one video and then condensing in the next, or vice versa. I don't know which way I'm going to do it yet. We'll find out. It'll be a great surprise. Okay, see you guys soon.